Hi everyone, I'm Jingwen, a PhD student from the Hybrid Body Lab at Cornell University. Today, I will present our work, Ecothreads, prototyping biodegradable e-textiles through thread-based fabrication. E-textile fabrication combines soft textile materials and hard-weld prototyping processes. As an emerging field, there have been mass prototyping efforts to explore the potential of e-textile products. In human-computer interaction, this often involves extensive swatch making by individual creators in STEM learning, makerspaces, or research labs. Regardless of the final application, the material choice is similar: conductive threads spun at industrial mills. These fiber materials are developed for excellent electrical and mechanical performance and are often blended with synthetic materials to achieve such properties. However, as a result, these rapidly prototyped e-textile projects become a mixture of textile and electronic waste that presents challenges to recycling. The permanency of the material can become an added environmental burden. In the HCI field, researchers have started looking into potential solutions to tackle the challenge of environmental impact originating from rapid prototyping. Sustainable e-textile practices, such as unfabricating, presents an approach using computational design to support the disassembly of mixed material prototypes. The exploration of biodegradable materials in HCI has also examined the destruction as a feature of the material. We present Ecothreads, a sustainable e-textile prototyping approach for fabricating biodegradable functional threads. We synthesized two thread-based fabrication methods, wet spinning and thread coating, to fabricate functional threads from biomaterials or modify natural fiber to achieve conductive or interactive functionality. Here's the Ecothreads design space. We've chosen wet spinning and thread coating as our fabrication methods, using biodegradable conductive and interactive materials ideal for thread-like structures. By selecting compatible binders, we enhance the strength and functionality of these threads. They can be incorporated into textiles via embroidery, weaving, knitting, braiding, and plying. This approach allows us to customize thread functions for a variety of applications, depending on the mix of conductive, interactive, and binder materials used. We present a sustainable e-textile lifecycle prototyping workflow for individual creators using Ecothreads. We highlighted 3 cycles that intertwine with each other: the human perspective, the textile materials perspective, and the electronic component perspective. We understand that biodegradability is not a one-off solution towards sustainability. However, this offers opportunities that prior work cannot address, especially when reuse or recycle is not an option with a particular material choice or function to achieve. Here, we detail our 2 fabrication methods for generating Ecothreads. Wet spinning is a process of dissolving polymers in a solvent and then extruding the filament fiber into a cross-linking agent to form the fiber. To achieve consistent extrusion, we modified a DIY syringe pump to wet spin biodegradable functional threads at desired thickness. The second fabrication option is thread coating, which offers the opportunity to turn natural fibers such as cotton threads into conductive ones. We explored biodegradable binder CMC mixed with silver nanowire or carbon nanotube dispersion to achieve conductive threads with consistent conductivity. To further understand Ecothreads, we characterized the material in terms of electrical and mechanical behavior. This characterization can guide users in customizing Ecothreads with desired properties. Please refer to our paper for details on the evaluation. To understand how Ecothreads could be adapted to existing e-textile practices, we conducted a workshop study with 5 practitioners with e-textile experience ranging from 3 to 12 years. Participants were shipped the needed Ecothreads supplies and conducted the study in their homes or studios. We chose to do so instead of having participants come to our lab, is to observe how people might integrate Ecothreads materials into their existing prototyping processes, using tools and compatible supplies that they were already familiar with. This participant has years of experience teaching e-textile related courses to graduate students, and has developed her own set of swatches for her teaching practice. In response to the prompt, she is interested in recreating the same sample swatches from her teaching sample book using Ecothreads. As in her classes, students would fabricate the sample swatches for practice and no longer use them afterwards. She used couching stitches to complete an LED circuit and used the sandwich structure to construct the band and pressure sensor. She was able to complete the exact same swatch design with the Ecothreads material without any design changes needed. This participant's prior textile artwork involves food as a component. For example, one of her prior work explores how serving food directly on a tablecloth can dye the tablecloth as an art performance. In this study, she chose to use pH-sensing alternate threads to weave a sample of a picnic blanket that can change color when food is directly placed on it, and can be left in nature to decompose after usage. We prepared alternate threads with pH-sensing extraction from red cabbage. She wove them on a 2-shaft floor loom, with the remaining warp from her prior projects using her standard weaving techniques, without any adjustment to the tension. For this participant, she was interested in fabricating a woven pocket that can heat up a stone for hot stone massage, or as a pocket heater. She dressed a 4-shaft table loom using her madder-root hand-dyed linen as warp, and chose silver nanowire-coated cotton thread with desired resistance as a heating thread. She designed a double weave pattern and wove the heating thread as weft on the top layer. After weaving the pocket, she inserted the stone she picked up during a recent hike into the pocket and powered the circuit to test the heating function. She is interested in returning the stone back to the trail to explore the notion of components that come from nature and also return to nature. We summarized our observation from the crafting session and post-study interview into 4 themes. All 5 participants successfully incorporated Ecothreads with their specialized e-textile crafting techniques, ranging from embroidery, weaving to knitting. All 5 participants emphasized the challenge of sourcing proper materials for their projects, especially when it comes to functional textiles with special properties. They do not have control over whether the thread materials are environmentally friendly. The hands-on experience using Ecothreads motivated them to explore sustainability in e-textiles even further. Interestingly, all the participants expressed transiency as a design prompt, initiated them to ideate transient use cases that they rarely considered, while their textile practice typically strive for a degree of permanence. To further explore the affordance of the Ecothreads approach, we prototyped 5 transient e-textile use cases. For example, this braided capacitive touch sensing hair extension can be trimmed or replaced after usage. In this application, we explored the integration of e-textile into daily objects. We wove thermochromic pigment-infused alternate threads with cotton yarns to create a bandbox band that indicates the warmness of the food. Elastic bands tend to lose their elasticity after a certain usage period, and we are interested in exploring using alternate-based thread as an alternative option. This is a pH-sensing panty liner using alternate threads infused with red cabbage extract. These threads change color from light blue to purple in response to pH level change. This application explores the gel-like properties of alternate threads when wet. We directly knit freshly spun alternate threads without a drying process using chunking gauge knitting needles and store the gel in the fridge. This patch can function as a cooling patch for fever and can be easily decomposed after usage. Sweat rate sensing provides non-invasive monitoring of body fluid loss. And textile-based sweat sensors have the unique advantage of wearability. We wove silver nanowires coated cotton threads to create an absorbing sweat sensing patch. This patch can be attached to sportswear and absorb sweat for sweat rate sensing. In our workshop study with e-textile practitioners and in developing the sample applications, we observe how the transiency of Ecothreads served unique design affordances. This distinctive approach sets it apart from conventional textile-based designs, particularly considering the prevalent cultural norm of crafting handmade textiles for prolonged use. We also observe how the transiency of Ecothreads may render it suitable for particular phases in the prototyping process. Ecothreads can be a suitable material for the early phase, low-fidelity prototyping processes in textile design, in which many swatches are rapidly fabricated before moving on to a high-fidelity final project. We also see this approach can be combined with other existing sustainable prototyping approaches, such as fabricating. In our workshop study, participants expressed their interest in gaining hands-on experience using the wet spinning setup to spin their own functional threads. Especially, the ability to craft their own threads in familiar kitchen or studio settings brought forth opportunities for intimate making in the context of functional threads. We hope that by providing the DIY syringe pump option, users can assess the trade-off between accessibility and performance for fiber-based or thread-based fabrication and choose the tools that best suit their practices. We present Ecothreads, a sustainable e-textile prototyping approach integrating biodegradable conductive and interactive threads into existing e-textile practices. We see our work situated in the broader cycle of sustainable design, and it is not a standalone nor exclusive approach. Biodegradable material choice can be coherently integrated into any existing e-textile practice to bring sustainability thinking into prototyping processes. Thank you for listening.